Welcome to a slow, beginner-friendly lesson on comparison operators, made for absolute beginners. Comparisons only. They produce bool values. We do not build full if programs here, that comes later in phase A. So far our operators have computed new values. 2 plus 3 gives 5. Comparison operators do something different. They ask a question. Is A equal to B? Is A less than B? The answer is never a number. It is always a bool, either true or false. There are 6 such operators, and together they cover every question you can ask about how two values relate. Think of them as the questions, where arithmetic was the maths. Questions, not maths. We begin with the most common question. Are these two values equal? 2 equals signs side by side ask exactly that. 5 equals 5 is true. 5 equals 3 is false. It works for text too. The string go equals the string go is true. Read the double equals as a question. Is the left the same as the right? Notice it takes 2 equals signs, not 1. That detail matters so much that we will spend a whole moment on it shortly. 2 equals asks. A comparison is a question you put to the computer. Is this equal to that? Is this larger? The computer never answers with a long explanation. It answers with a single word, true or false. That tiny answer is the foundation of every decision a program ever makes, from login checks to game logic. Yes or no, always. The partner of equality is inequality. An exclamation mark followed by an equals sign asks, are these two values different? 5 not equals 3 is true, because they differ. 5 not equals 5 is false, because they are the same. The string go not equals stop is true. Read exclamation equals is not equal, or is different from. Equality and inequality are a perfect pair. One asks are they the same, the other asks are they different, and exactly one is always true. Are they different? Next come the ordering questions, written with the same angle brackets you know from school. 3 less than 7 is true. 7 less than 3 is false. 8 greater than 4 is true. 4 greater than 8 is false. The pointy side of the bracket always faces the smaller value, just as you learned in maths class. These two operators let your program rank anything that has an order, ages, prices, temperatures, scores. Which way does it lean? Sometimes you want to include the boundary itself. Less than or equal is written less than followed immediately by an equals sign. 5 less than or equal to 5 is true, because they are equal and that is allowed. 5 less than or equal to 4 is false. Greater than or equal works the same way. 10 greater than or equal to 10 is true. Use these whenever a limit is inclusive, like an age that must be at least 18, meaning 18 is permitted. Include the boundary. Every comparison splits the world cleanly in two. Either the answer is true, and one path is taken, or the answer is false, and another path is taken. There is no middle ground, no maybe. This binary simplicity is what lets programs make reliable decisions millions of times a second without ever getting tired or confused. A clean split in two. Let us make one point very clear. Every comparison returns a bool, either true or false, and never anything else. It never returns 1 or 0, never maybe, never a string. Because the answer is a real value, you can store it in a variable and use it later. A variable like isReady could hold the result of age greater than or equal to 18, and then your program can act on it. The bool is the currency of decisions in Python. Comparisons mint that currency. The answer is a value. Here is the single most important detail in the whole lesson. 1 equals sign assigns a value. It says, store this. Score equals 90 stores 90 into score. 2 equals signs compare. Score equals 90 asks, is score currently 90, and returns true or false. The two look almost identical but do completely different things. Burn this into your memory now. 1 equals stores, 2 equals ask. Almost every beginner mixes them up at least once. 1 stores, 2 ask. Why does this confusion bite so often? Because mixing the two up does not crash. If you write 1 equals when you meant 2, Python cheerfully assigns a new value, silently overwriting your data. Or in some contexts it answers true no matter what, hiding a logic bug. Either way, nothing alerts you. The program runs, the data is wrong, and you stare at perfectly working code with a wrong result. That is why we slow down on this one detail. It is the silent kind of bug, the hardest to spot. Silent bugs bite worst. Here is the trap that has wasted more beginner hours than almost any other. 1 equals sign assigns a value. 2 equals signs ask a question. Mixing them up does not crash. It silently changes your data when you only meant to check it. Spotting this difference early is worth its weight in gold. One symbol, huge difference. Comparison is not just for numbers. Text can be compared too, and the rule is dictionary order, The same way words sort in a book. Apple less than banana is true, because apple comes first alphabetically. Apple less than apricot is true, because the shared letters match and the P beats the R. One surprise worth knowing, uppercase letters rank before lowercase in Python. So capital banana less than lowercase apple is true. Letter case matters, and we will revisit it when we study strings in depth. Dictionary order, a few more examples to build intuition. Car less than card is true, because car is a prefix of card, and the shorter word comes first. Here is a subtle one. The text 100 less than the text 9 is true, even though the number 100 is larger. That is because text compares character by character, and the character 1 ranks before the character 9. When digits arrive as text, they sort as letters, not as numbers. This is why you must convert digit text to integers before sorting them numerically. Letter by letter. A pleasant feature of Python is that you can chain two comparisons together, and it reads almost like plain English. 18 less than or equal to age less than or equal to 65 asks, is age within the working age range? For age 30, that is true. Python expands it quietly into age at least 18 and age at most 65. Chaining is clearer than writing the variable twice, and it matches how the rule is written on paper. Reach for it whenever a value must sit inside a band. A range in one line. Comparison operators feel small, but they are the bedrock beneath every if statement, every loop, and every rule your program enforces. Get comfortable with them now, and the next lessons on conditions and loops will feel natural. Skip past them, and everything built on top feels shaky. Let us unpack how chaining works under the hood. When you write 18 less than or equal to age less than or equal to 65, Python checks both comparisons and joins them with AND. The variable is evaluated once and tested against both bounds. The result is true only when the value sits within the whole range. This is far cleaner than writing age greater than or equal to 18 and age less than or equal to 65. Chaining is a small kindness Python offers, and it keeps range checks readable. Both ends, quietly, a useful detail. When you compare an integer and a float that hold the same value, Python says they are equal. 1 equals 1.0 is true, because the values agree even though the type labels differ. Even more surprising, 0 equals false and 1 equals true, because in Python bool is a kind of integer under the hood. Do not lean on that last fact too hard, but know it exists. The key lesson is that equality compares values, not the type labels attached to them. Value over label. Because a comparison returns a real value, you can store it. Score is 72, and past is score greater than or equal to 60, which is true. Print past and you see true. Ask its type and you get bool. From this point on, past is a flag your program can consult, maybe to show a congratulations message or to grant access. This pattern, compute a comparison, store the bool, act on it later, is the heartbeat of every decision-making program. Keep the answer. Comparison is not only for numbers. Text can be compared too, and the rule is surprisingly familiar. Words order themselves just as they do in a dictionary. So the same operators that rank numbers can rank names, sort titles, and decide which word comes first on a page. A quick challenge to lock it in. Predict each answer before reading on. 7 equals 7 is true. 8 not equals 8 is false. 4 less than or equal to 4 is true, because equality is included. The letter M less than the letter N is true, since M precedes N in the alphabet. If those felt automatic, you own the operators. If one tripped you, revisit that symbol for a moment. Predict before you peek. Here is the pattern in a realistic shape. A shop offers free shipping on orders of 50 or more. Total is 35. Free shipping becomes total greater than or equal to 50, which is false. The program now has a clean flag it can check before showing the checkout page. Notice how readable this is. The line reads like the business rule itself, total at least 50. That is the quiet power of comparison operators turning plain rules into runnable logic. Plain rules, runnable logic. 2 pitfalls worth holding on to. First, never use a single equals to compare values. 1 equals assigns and silently changes your data. Always use 2 equals to ask a question. Second, digits wrapped in quotes are text, so they sort as letters, and the text 9 can outrank the text 100. Convert digit text to integers before comparing numerically. And remember that uppercase letters sort before lowercase. When you are unsure of an ordering, convert the values and test. A quick test now beats a silent bug later. Small details, big savings. Let us hold the whole lesson in one breath. There are 6 comparison operators: equals, not equals, less than, greater than, less than or equal, and greater than or equal. Every one returns a bool, true or false. 1 equals sign assigns a value, 2 equals signs compare values, and mixing them up is the classic beginner trap. And text compares in dictionary order, letter by letter, with uppercase before lowercase. If those sentences feel solid, you own the whole family of comparisons. 4 true sentences. The takeaway, compressed to one line. Comparison operators ask a question about 2 values, and the answer is always a bool, true or false. Remember the golden rule, 2 equals compare, 1 equals assigns, and never mix them. In the next lesson we bring everything together, arithmetic, comparison, and the logic words and, or, not, into a single expression. That final lesson closes phase A.2. Take a breath. You just finished comparisons. Lesson done. Thanks for watching. Next, combining expressions.